So, hello everyone. Today we see how to implement 8:1 multiplexer using VHDL. Before we going to implement, we just see the block diagram, circuit diagram, and truth table of the 8:1 multiplexer. So this is the block diagram. So for 8:1 multiplexer, you want 8 input, 1 output, and that output will be selected by using select line input. Okay. So how does the select input will be selected by using 2 to the power n. Okay, the n will be the select input. So 2 to the power n equal to output. So 2 to the power 3 equal to 8. So using 8 input and 2 to the power 3 is the, so that 3 will be the select input. If you giving for the 4:1, must mean 2 to the power 2 equal to 4 input. So 2 will be the select input. So this is the circuit diagram and the expression, and this is the truth table. Now we see the same. Okay, so I'm using the IDINS 14.7 ISC. So for that, just go file, click new project. Here give the file name, and you give 821 mux. Click next, and this is the project setting. Here just select the FPGA evolution development board. If you want to implement this code in hardware, means just select the board, otherwise just not specify anything, and select the speed and language going to use. I'm going to develop in VHDL. So I'm selecting the VHDL language and click next and finish. So yes, just select the new source. Here just select VHDL module. Here give the file name, give mux. Here I'm using 8 input. So for that we go for I0, I1, I2, I3, I4, I5, I6, I7. So 8 input and 3 select line, X0, X1, X2. So select line will be the bidirectional, the output 1 only go. Okay, so I declare the input output different port. So this is the already we declare input and output 1. So now we go for the code. If you see the expression, you want to give this expression. Okay, so I will use 1 2 3 4 5 6 7 8. Okay, so we go for A, B, C, D, E, F, G, H. Okay, now this is the logic. Okay, so for A I will give is not, not S1, not S2, and D not. Okay, so not is not and not S1, not S2, and B. For B, want to use not is not S1, S2, D1. Okay, not is not and We can use other method also by using if and else statement. I'm going for the logic gates. Okay, not s1 and s2 and d1. Okay, next C. If you for C we use not is not s1, not s2 and d2. Okay, not s0 and s1 and not s2 and d2. Okay, next we go for D. For D, if you see means not is not, s1 is 2, is 2. Okay, for E, is not. D1, D2, D3, D4, so s1 not here. Okay, so here s2 not and d6. So final one H. Here views is not and s1 and s2 and d7. Okay, after completion, so A or B or C or D or E or F or G or H. Okay, so we develop the code. Now we check whether there is any error or not. Just save. So 7 so save and run the code. there is an error. So what this means, we want to check the error. So I'm using D0. So sorry, we're using I1, right? I want to change D to I. D to I. Now save and again run. So this is out. Okay, now this syntax will be run. Okay. So there is no error. Now we check the RTL semantic. So after if it is the code, we want to check syntax whether there is any error, means we want to correct that one. After the correction, we want to check the RTL semantic. After, so this is RTL semantic. So we using 0 to 7 8 input and 1 output, another one are bidirectional and select lines. Okay, so this is the semantic diagram of 8 to 1 mux. Next we see the LUTs, how much we are using. So we're going to use 1 2 3 4 5 6 7 8 9 10 11. So 11 LUTs are we used in FPGA. So if we check all the LUTs, means there you can able to see the how much logic gates we are using. Okay. So after that completion, we want to check the design summary. For that, just to go synthesis report. There you can able to see how much input output we are used and how much LUTs are we used. So we use 20 input output. Why? Because means 7 input and bidirectional also we use, and output is 1 8 and 12 bidirectional. After that LUT is 11. Okay, so we want to see how much delay we're going to get. 10.974 nanosecond delay. Okay. So there is lot of way to develop the code. I'm using the logic case. There is another way also there, that is the if and else statement. If you that means, then the usage of the input output and logic gate will get reduced, so that delay also will get reduced. So let's check the analyze power distribution in place and rule section. Keep your speed -5, then only the running processor will speed. So implement design is running, translating map. After that place and route, then designing power distribution will run, then the X power analyzer window will be open. So now power distribution is running. So 0.60 is the supply power. Let's see the simulation. So for that, just we want to create test bench. For that, click VHDL test bench and create the name mux-tb. Next, next finish. So here just we going to select the output is depend on the input. Okay, so input whatever the input 1110 like that, and we give, so just give, we remove the inbuilt one. So I'm giving 0101 like that. Okay, we will get in real time, you will get whatever the input data. Okay, so input data whatever we want to you will get, and we select the output which one we going to use. Wi-Fi. I6 0 I7 okay, we give input one. Next we give the select lines. Possibility of select line is 0 0 S1 0 S2 0. And next wait for next 0 0 S1 0 S2 1. Next yes 0 1 0. Okay, so just we give this select lines and we check. Okay, so simulation behavior model is want to select. So after running is finished, simulation window will be open. There is no any error. So this is the simulation window. Here you can check the input. Okay, so select lines is I'm selecting 0 0 1 force constant 1. Okay, so 0 1 1 means then output O will be 1. Okay, because if you check means 0 1 1 0 1 1 means I3. So if you see I3 is 1, so the output will be 1. So what we designed is correct, which okay. So we design 8 is to 1 marks, and we create test bench. We see the output of the semantic output and technological output, and we also analyze the parameters, power, area, and delay. Okay, thank you.